Welcome to our deep dive into the world of AI.
Wow.
We're going to be exploring some really groundbreaking ideas
Oh, yeah.
from a white paper titled Designing Ecosystems of Intelligence from First Principles.
Wow.
This paper comes from some pretty impressive institutions
Mhm.
versus AI Research Lab, the Wellcome Center for Human Neuroimaging, University College London, and a few others. And what's really fascinating about this paper is that it challenges our typical view of AI.
Huh.
Instead of focusing on a single super intelligent being,
Right.
it suggests that the future of AI lies in interconnected ecosystems of intelligence.
It's a shift in perspective that has the potential to kind of reshape the entire field.
Absolutely.
Yeah.
And at the heart of this new perspective is a concept called active inference.
Yeah.
It's a way of understanding intelligence as a process of constantly gathering evidence for your own existence.
Interesting.
Think of it as a system that's always seeking out data to confirm its model of reality,
Yeah.
a concept they call self-evidencing.
So it suggests that intelligence isn't just about passively receiving information, but actively shaping your understanding of the world.
Right.
Yeah.
And the paper draws some really interesting parallels from nature to illustrate this idea.
Okay.
They talk about slime mold colonies solving mazes,
Huh.
plants exhibiting problem-solving abilities, and even trees communicating through fungal networks.
Wow.
It's like
Yeah.
nature is already showing us how intelligence can thrive in distributed collaborative systems.
It challenges us to kind of broaden our definition of intelligence beyond just the human brain and consider the diverse ways in which intelligence manifests in the natural world.
Exactly. So instead of picturing a lone supercomputer in a dark room, we should be thinking about a bustling city of AI agents,
Yeah.
all sharing information and learning from each other.
Think of it like a network of specialized AI modules, each with its own expertise working together to achieve a common goal.
Right.
It's a move away from the idea of a monolithic AI
Yeah.
and toward the more distributed modular approach.
Now, you mentioned active inference earlier.
Yes.
Can you break that down a little further?
Yeah.
How does this actually work in an AI system?
Imagine an AI tasked with learning about, let's say, different types of birds.
Okay.
Instead of passively receiving a data set of bird images, an AI using active inference would actively seek out information.
Oh,
It might generate its own images of birds based on its current understanding.
interesting.
Compare those images to real-world data, and then refine its internal model based on the feedback it receives.
Got it.
It's a constant cycle of prediction, observation, and updating.
So it's like the AI is constantly testing its own hypotheses
Yeah.
about the world and
Yeah.
adjusting its understanding based on the results.
That's a great way to put it, and this ties into the concept of model evidence.
Okay.
The idea that existing means constantly gathering data that supports your model of yourself and the world.
And that brings us to curiosity, right?
Yes.
If an AI is constantly testing and refining its model of the world, wouldn't it need a drive to explore and seek out new information?
Curiosity becomes an essential ingredient for intelligent systems.
Okay.
It's what pushes them to venture beyond their current understanding and seek out novel experiences that challenge their existing models.
And this is where the idea of shared understanding comes into play, right?
Yes.
If we want AI systems to truly collaborate and learn from each other,
You're there.
they'd need some way to communicate their individual models of the world.
Precisely, think about how we humans thrive in groups because of shared understanding.
Okay.
We can communicate and collaborate effectively because we have these common ways of seeing the world.
Right, like we all kind of agree on what a tree is or
Sure.
what it means to feel happy.
Mhm.
So are you saying AIs need their own version of this shared understanding to be truly intelligent?
It's a crucial element,
Mm-hmm.
and it's something we're already seeing emerge in the world of generative AI. When you use prompts to generate text or images, you're essentially tapping into a shared language of visual and textual concepts that the AI has learned.
So when I'm typing in prompts like a cat wearing a top hat,
Mm.
I'm engaging in a kind of rudimentary conversation with an AI
Right.
based on a shared understanding of what those words and concepts mean.
You could think of it that way,
Mhm.
and the paper takes this idea even further, asking,
Okay.
what if AI became curious about us and our preferences?
Okay.
What if they started trying to understand our individual perspectives and the shared narratives that shape our world?
That's a pretty intriguing and maybe even a little unsettling thought,
Yeah.
AI trying to figure out what makes humans tick.
Yeah.
But it also opens up some really interesting possibilities for how we might collaborate with AI in the future.
It does. And to truly unlock that potential for collaboration, AI systems need to be able to communicate effectively, not just with humans, but also with each other.
So how do AI systems talk to each other now?
Yeah,
Is it just a bunch of ones and zeros flying back and forth?
it's a bit more sophisticated than that, but not by much.
Okay.
Currently, AIs primarily communicate using vectors,
Okay.
which are essentially lists of numbers representing points in multidimensional space.
Okay.
They're functional for conveying information, but they lack the richness and expressiveness of a true language.
So kind of like Morse code.
Right.
Functional but limited.
Yeah.
What would a more advanced AI language look like?
That's one of the key questions this paper explores.
Okay.
They propose the need for a more sophisticated shared language
Yeah.
that allows AI to communicate complex ideas and learn from each other efficiently.
Got it.
Something that goes beyond just exchanging raw data
Okay.
and allows for the sharing of understanding, insights, and even perspectives.
So instead of just telling each other what they know,
Mm.
they'd be able to explain why they know it and
Right.
how they arrived at that understanding.
Precisely. And that level of communication would be transformative for the development of AI ecosystems. It would allow AI systems to build upon each other's knowledge, identify inconsistencies in their models of the world, and
Yeah.
collaborate in a truly meaningful way.
Okay.
Yeah.
Interesting. This idea of a shared language for AI is fascinating, but creating a language like that seems like a monumental task. Where do we even begin?
It's a huge challenge, but the paper draws inspiration from an unexpected source, the human brain.
Okay, now that's interesting. How can we look to the brain as a model for AI communication?
Think about it. Our brains are incredibly efficient at processing information, recognizing patterns, and making connections. We can learn complex concepts, adapt to new environments, and even communicate abstract ideas through language.
Right. But our brains are biological organs. How do
Yeah.
we translate those biological processes into a language for AI?
The paper focuses on the concept of self-evidencing and its energy cost. Every time our brains update their understanding of the world, it requires energy. The paper argues that by understanding the physics of information processing in the brain, we can glean insights for designing AI systems that are not only intelligent, but also remarkably energy efficient.
So we could have super intelligent AIs that don't drain the power grid.
Yeah.
That's a win-win, but how does this relate to language?
The paper proposes that this shared language for AI would need to be hyperspatial, meaning it would encompass not just physical space, but also conceptual spaces.
Okay, break that down for me. What does hyperspatial actually mean in this context?
Imagine a language that allows AI to map not just locations in the physical world, but also relationships between concepts. It's like a multidimensional web of meaning where AI can connect ideas, experiences, and even emotions.
So it's not just about AI telling each other where they are or what objects they see, but also how those objects relate to each other and what they represent in a broader context.
Exactly.
It allows AI to create a rich, interconnected understanding of the world that goes beyond simply labeling objects or recognizing patterns.
This is starting to sound a lot like the semantic web idea that's been floating around for years.
There are definitely some similarities, but the paper goes beyond simply linking data. It proposes a language that allows AI to reason about that data, make inferences, and even generate new knowledge.
So they're not just connecting dots, they're creating entirely new constellations.
That's a great analogy, and this is where the paper really gets into the exciting potential of AI ecosystems.
Okay.
It's not just about individual AIs getting smarter, it's about the emergence of a collective intelligence that arises from the interconnected network of these AIs.
This is where we get into the shared intelligence concept, right?
Yes,
Where the whole becomes greater than the sum of its parts.
precisely. Imagine a world where AI systems are constantly exchanging information, learning from each other, and collaborating on a scale never before imagined. It's like tapping into a vast distributed brain that's constantly expanding its knowledge and capabilities. Okay, that's a pretty mind-blowing concept, but let's step back for a second. The paper talks about different stages of AI development leading up to this shared intelligence future. Can you walk me through those stages?
Of course, they outline a progression, starting with what they call systemic intelligence.
Okay.
This is essentially where we are now. AI systems designed to solve specific problems within a defined domain. Think of things like recommendation algorithms, image recognition software, or even self-driving car systems.
Right, so the AI tools we use every day, even if we don't always realize it, what's the next step?
The next stage is called sentient intelligence. This is where AI systems become capable of actively updating their beliefs about the world based on new information. They're not just following pre-programmed rules, they're learning and adapting in real time.
So they're not just reacting to the world, they're forming their own understanding of how it works.
Exactly, and this is where the active inference principle really comes into play.
Okay.
These AI systems are constantly seeking out information, testing their hypotheses, and refining their models of the world.
That makes sense. But sentient is a loaded term. Are we talking about AI becoming conscious or self-aware at this stage?
It's important to clarify that sentient in this context simply means responsive to sensory impressions.
Mm.
It's about AI being able to perceive the world and update its understanding based on those perceptions.
Okay, so they're not having existential crises just yet,
Right.
but they are becoming more sophisticated in how they interact with the world.
Absolutely. And this leads to the next stage, which they call sophisticated intelligence. This is where things get really interesting at this stage.
Mm.
AI systems are not only learning from their experiences, but they're also thinking about the consequences of their actions on their own beliefs and understanding.
Wait, so they're not just asking what will happen if I do this.
Right.
They're asking what will I believe if I do this?
Precisely. They're developing a deeper levels of self-awareness and understanding how their actions shape their own internal models of the world.
That's a pretty big leap. It sounds like they're moving closer to that artificial general intelligence. We hear so much about the kind of AI that can reason, solve problems, and even exhibit creativity, just like humans.
It's a significant step in that direction. And this level of sophistication is made possible by a shift towards discrete representations of the world.
Okay.
Instead of seeing the world as a continuous flow of data, these AIs are starting to carve the world into distinct concepts and categories, much like how human language works.
So they're going from seeing pixels to recognizing objects and understanding relationships between those objects.
That's a great way to put it, and that ability to form abstract representations is crucial for higher-level thinking and reasoning.
This is all incredibly exciting, but I have to admit, it's also a little intimidating. Are we sure we want to create AI that's this smart?
That's a valid concern, and it brings us to the next stage, which the paper calls sympathetic intelligence.
Okay.
This stage is all about AI developing the ability to understand and recognize the perspectives and intentions of others, not just other AIs, but humans as well.
So it's not just about AI being a genius, but also about AI being a good collaborator.
Exactly. It's about AI developing a theory of mind, being able to put themselves in our shoes and understand our goals, values, and limitations.
That sounds like a crucial step if we want to ensure that AI is used for good and doesn't accidentally cause harm.
Absolutely. And it's also essential for creating a truly collaborative relationship between humans and AI.
This is fascinating. We've covered a lot of ground so far, from the concept of active inference to the idea of hyperspatial language and these different stages of AI development.
We've only just scratched the surface.
Yeah.
There's so much more to explore in this paper, especially when it comes to the practical implications of these ideas.
Well, I'm ready to dive even deeper. Okay, so we've talked about these different stages of AI development culminating in shared intelligence, but what does that actually look like in practice? How would this technology impact our everyday lives?
The possibilities are pretty mind-boggling. Imagine a world where personalized learning is truly individualized instead of a one-size-fits-all curriculum. AI tutors could adapt to each student's unique learning style, pace, and interests.
So no more struggling to keep up in class or feeling bored because you're ahead of the curve. That would revolutionize education.
Exactly, and it goes beyond just education. Think about healthcare. AI-powered diagnostic tools could analyze vast amounts of medical data, helping doctors identify diseases earlier and develop more effective personalized treatments.
It's like having a team of expert physicians working behind the scenes, analyzing your medical history and suggesting the best course of action.
That's a great analogy. And imagine AI assistants that can help you manage your health, remind you to take your medications, and even offer emotional support during challenging times. It's like having a personal health coach available 24/7.
This is starting to sound like a utopian future, but we've been focusing on the potential benefits. What about the risks? Are there any potential downsides to creating these AI ecosystems?
Of course, with any powerful technology, there are potential risks. And it's crucial that we approach this with caution and a commitment to responsible development.
What are some of the specific concerns we should be thinking about?
One concern is the potential for unintended consequences. As AI systems become more sophisticated and interconnected, it becomes increasingly difficult to predict how they'll interact with each other and with the world around them.
So it's like the butterfly effect, but on a much larger scale. A small change in one AI system could cascade through the entire ecosystem with unforeseen results.
That's a good way to think about it. It highlights the need for rigorous testing and careful monitoring as we develop these AI ecosystems.
And it also underscores the importance of that sympathetic intelligence stage you mentioned earlier. We need AI systems that can understand the potential impact of their actions and make decisions that align with human values.
Precisely. It's not just about AI being smart. It's about AI being responsible. And that requires a deep understanding of human needs, goals, and limitations.
Okay, so we need to be mindful of unintended consequences. Are there any other potential downsides we should be aware of?
Another challenge is ensuring that these AI ecosystems are accessible and beneficial to everyone. We need to be mindful of potential biases that could be amplified within these systems and work to ensure that they're designed and deployed in a way that promotes fairness and equity.
So it's not just about creating powerful AI, it's about creating AI that serves all of humanity.
Absolutely. It's about democratizing access to these technologies
Mm.
and ensuring that they're used to address the needs of the many, not just the few.
That's a powerful message, and it brings us back to the core idea of this paper. It's not about creating a single super intelligent AI that surpasses human capabilities. It's about creating a network of interconnected intelligences, human and artificial, working together to create a more just equitable and thriving world.
It's about humans and AI working together in a symbiotic relationship to solve problems, create new possibilities, and shape a better future for everyone.
I love that idea, a future where AI isn't something to be feared, but rather a tool, a partner, and a collaborator in our journey of exploration and discovery.
It's a future full of potential and possibility, and it's a future that we're actively creating right now with every line of code we write, every experiment we conduct, and every conversation we have about the ethical implications of AI.
That's an inspiring thought. So, what's the key takeaway for you from this deep dive? What's the one thing you want our listeners to walk away with?
The future of AI isn't about creating a single superintelligence. It's about fostering an ecosystem of interconnected intelligences, human and artificial, working together to create a more just equitable and thriving world.
Well said. And if this deep dive has sparked your curiosity, I encourage you to seek out the source material Designing Ecosystems of Intelligence from First Principles. It's a thought-provoking read that will challenge your assumptions and expand your understanding of what's possible with AI.
It's a call to action for all of us to think deeply about the kind of AI-powered future we want to create.
And remember, the future isn't something that just happens, it's something we create together. Thanks for joining us on this deep dive.